The sun, for all its life-giving warmth, can sometimes unleash violent bursts of energy. These outbursts, called solar flares, are intense flashes of radiation that erupt from the sun's surface. They're often followed by something even more dramatic, a coronal mass ejection, CME, a giant bubble of magnetized plasma hurtling through space. If one of these CMEs is aimed toward Earth, the results can be serious. Power grids could overload, satellites might malfunction, and communication networks could be disrupted. Even the flare's radiation alone can interfere with satellite operations and radio signals. The trouble is, we can't reliably predict when a flare will happen. Once one is detected, the clock starts ticking, and scientists have only minutes to alert operators to protect satellites, adjust power grids, or safeguard astronauts. But now there's hope for earlier warnings. Using data from NASA's Solar Dynamics Observatory, researchers have spotted a promising sign: distinctive flickering in enormous arcs of superheated plasma, called coronal loops, that rise from the sun's atmosphere. This flickering seems to happen in magnetically active regions just hours before a large flare erupts. Emily Mason, a heliophysicist at Predictive Science in San Diego, and her team studied 50 strong flares. They found that the ultraviolet light from these coronal loops began to fluctuate erratically a few hours before a flare. It gives us 1 to 2 hours warning, with 60 to 80% accuracy, that a flare is coming, Mason says. That may not sound like much, but even a small head start is valuable, says Matthew Owens, a space physicist at the University of Reading in England. If we want to be able to predict solar storms earlier, then we have to predict when the flare will happen. Small gains there are valuable. What makes this breakthrough especially promising is that Mason's team used a near real-time data stream with only about an hour's delay. Rather than waiting for fully processed data, which can take weeks, they focused on flares at the sun's edges or limbs, because from Earth's perspective, that's where the light from the coronal loops is easiest to detect. Flares from the eastern limb will drift away from Earth as the sun rotates, but those from the western limb could be heading straight for us. The limitation right now is our viewpoint. We can't see coronal loops forming elsewhere on the sun as clearly. That could change in 2031, when the European Space Agency plans to launch a spacecraft called Vigil, which will give scientists a side-on view of the sun. Being able to see the sun from more different angles is the single most important thing that we can do to improve our predictions, Mason says. Her hope is simple: that better warnings will help protect both astronauts and the electrical systems we depend on every day.